A red-black tree is a type of self-balancing binary search tree with additional rules to ensure that the tree remains balanced after every insertion or deletion. It is widely used in applications like tree map or tree set in Java due to its efficiency. Let's see some key properties of a red-black tree. Every node is either red or black. The root node is always black. Red nodes cannot have red child. That is, no two consecutive red nodes. Every path from a node to its leaf node has the same number of black nodes. That is black height. A null or a leaf node is always black. Let's see the operations in the red-black tree. The first operation is insertion operation. Example, insert nodes into a initially empty red-black tree. First insert 10. The first node becomes the root node and it is colored black. Next insert 20. Insert 20 as the right child of 10. It is colored red. New nodes are initially red. Now insert 30. Insert 30 as the right child of 20 and color it as a red. Now the red-red violation occurs. 20 and 30 both are red. So to fix this problem, we will perform a left rotation on 10. Recolor 20 as a black and 10 as a red. Now insert 15. Insert 15 as a left child of 20, it is colored red. Here no violation occurs, so no rotations are needed. Now insert 25 as the left child of 30, it is colored red. Red-red violation occurs between 30 and 25. To fix this problem, perform a right rotation on 30. Recolor nodes to maintain red-black tree properties. Now let us see the deletion operation. Deletion in a red-black tree is more complex because it can create violations that need to be fixed with rotations and recoloring. Here is a simplified example. Delete 10 from the tree. Remove 10. Recolor or rotate as needed to maintain balance and red-black properties. Key rotations in red-black tree. Left rotation used to fix right-heavy trees. After rotation it looks like this. Now perform right rotation on this used to fix left heavy trees. After rotation it looks like this. Why use red-black trees? First one is balanced tree. Ensures height is always logarithmic, making search, insertion and deletion efficient. Second, applications. Used in databases, compilers and as a base for tree map and tree set in Java.